Buongiorno amici. I want to start this presentation with the picture of a video game. Perhaps you remember this game? It turned 30 this week. It's already 30 years since it was released. And the goal of this point and click adventure was to become a pirate. To be more precise, a mighty pirate. Yeah, I think you've already found out the name. It was Monkey Island. It was one of my most favorite adventure games back then. But on my machine, it did not look like this, it did look like that. Because I had a more traditional PC, and when the PC was originally designed, they did not focus on graphics. They focused on serious business topics like spreadsheet or text processing. And also, they did not focus on sound and audio. Let me show you how this video game sounded on my machine. Let's click here on my prepared YouTube link. Let's maximize it. Yeah, I think that's enough. As you see, it was an awful sound. This was the integrated PC speaker, as it was called. But my friend Christoph had a better machine. And on his machine, on his PC, it really looked like this. He had all those colors, he had a nice display, and he even had a better sound. Let me click here on this link to show you how it sounded on his machine. Quite a difference, isn't it? So perhaps you are wondering why the very same video game looked differently and sounded differently on two different PCs. And the answer is, as mentioned before, first of all, the PC has been designed for business use cases and not for great audio and video, but it has also been designed for extensibility. Each and every PC had a lot of slots for extension cards. And you could plug in this or that extension card, for instance, a sound blaster, which allowed you to get better audio. Or a video adapter for better monitors for getting more colors. And obviously, Christoph had all those extensions. I didn't have it. If you look at those extension slots, they can be seen like something that is consuming an interface if we use terms of computer programming. And the sound card, or in general the extension card, could be seen as something that is implementing an interface. And so you can easily extend an existing system and make it to do new stuff. And this leads to the question I want to answer today. The question I want to answer is how to implement such a plugin system with Angular. And this boils down to another question, namely how to load separately compiled and deployed source code. Because a plugin is implemented in isolation. The creator of the application does not know of the plugin, because that's why it's a plugin. So the plugin is built in isolation, it is compiled separately, deployed over there, and then at runtime your application needs to load it to get new tricks. To demonstrate all of this, I have prepared a tiny example. It is a workflow designer, a plugin-based workflow designer. And now I want to show you all of this in action. So let's have a look here. This is my workflow designer. I can click here to add some tasks. And the nice thing is those tasks are not built in. No, those tasks are provided by a plugin deployed at another server. The same holds true for that task and so on and so forth. So to prove you that those tasks come from another origin, I have here this origin started. It's my micro front at one, which is providing the upload and the download task. And here I have another micro frontend providing the analyze and enrich task. And even if we reload this page and if we press F12, then we will see in the network tab that those tasks are loaded on demand from a different server. And if you look closely here, this is really more than just lazy loading, because here you see this task comes from localhost 3000, or the other task comes from localhost 3001, while my application itself is hosted on localhost 5000. Different origins, different deployments. At runtime, everything is loaded into this shell, into this workflow designer. Yeah. How to implement such a thing is what I want to show you in this presentation. So let's jump a bit to the right location of my slides. Yeah, and this brings me to the contents of this presentation. First of all, I want to show you how you can use module federation for this. Module federation is quite a new feature which comes with Webpack, and Webpack was released some days ago, at least the newest version of Webpack, Webpack 5. Then we will talk about dynamic module federation, which is also something we need for our workflow designer. And then I want to show you how to use this together with Angular. I'm calling this federated Angular. But before we start, let me introduce myself. I am Manfred. I am a trainer and consultant for Angular. I'm doing a lot of workshops, especially remote workshops in times like this. After Corona and before Corona, I also did a lot of in-house workshops and consultancy. And I'm quite connected to the Angular community. I live in Austria, I do a lot of stuff in Germany and sometimes in other countries around the world, which is a bit easier now as everything takes place remotely. Okay, let's get started with the first chapter. Let me tell you a little something about Webpack 5 module federation. The big question module federation is answering is how to load separately compiled code. And perhaps you say now, well, Manfred, that cannot be that difficult. Because, we have this dynamic import statement. It allows us to point to a different origin, and so we can load something from over there. And even before we had the dynamic imports introduced with ECMAScript 2017, we had something like require, and it served a similar purpose. But I'm telling you now, well, this does not work with dynamic import, especially if you use a bundler like Webpack or a bundler like the CLI, which is using Webpack underneath the covers. Because all those bundlers assume that everything is known at compile time. Not at runtime, but at compile time. Everything is used at compile time, everything is compiled at compile time, everything is analyzed and optimized. Think about tree shaking. It only works if you have everything in place when compiling, when bundling the solution. And so something like this was not really possible in the past, especially without using dirty tracks. But module federation, which ships with Webpack 5, is changing this. With module federation, you get two roles. The first role is the host. You could also call it the application shell, which is capable of loading other stuff. And the second role is called remote. I also call it the micro frontend. It is one piece of software loaded into your host, loaded into your shell. And then you can configure the shell as well as the micro frontend, the host as well as the remote. You just need some tiny configuration settings like this here. With this setting, I'm saying, hey, this shell can load a remote. I'm calling this remote MFE1, which stands for Micro Frontend 1 here, and it points to another application, and over there, this application is also called MFE1. Over there in this application, I can expose stuff like this component or that component, or even a configured Angular module. Here I'm just exposing a component. In our example, the component is the task component we've added to our workflow designer. It gets a public name and of course it has a private name. And then something wonderful happens. Then I can use a dynamic import which is using the both configured names, and so this import points over to this other application, and this allows me to load the component from over there. The best of this is Angular does not even notice that I'm loading something from another application. From Angular perspective, this is just a dynamic import, this is just lazy loading. But Webpack is doing the heavy lifting underneath the covers. Webpack knows about the configuration that it has to grab over there and load something from this different, separately compiled application. So it's really as easy as that. Perhaps you're wondering now how the shell finds out about the URL of the micro frontend. And well, for this you need to know that Webpack is creating a remote entry for the micro frontend. A remote entry which is just a tiny file, just a tiny amount of bytes you should load into your shell. This tiny amount of bytes tells the shell and the Webpack runtime API how to load this very remote. You can load it statically with a script tag, you can load it with a dynamic script tag, and there are even more dynamic ways like leveraging the Webpack runtime API. You find it in your global namespace when your application was built with Webpack. Also, it is possible that we share some libraries. For instance, I could say, hey, let's share Angular core. For this, just configure Angular core on both sides as a shared library. And in this case, Angular core is only loaded once. It is only loaded once and it is shared across all your micro frontends, all your remotes. That's a huge benefit because obviously you don't want to load Angular 10 times when having 10 micro frontends. And as mentioned before, this is really a great deal for micro frontends, which means you have one application that is implemented in isolation, that is implemented separately and loaded into another application on demand. That means different teams can implement different micro frontends, and for the user everything is loaded into a common shell. Perhaps you say now, well, that seems to be great for real micro frontends, but in our case we don't even know the plugins up front, our workflow tasks. We don't even know their number or where they are located. So how can we configure them up front? And this leads me to the second topic I've prepared for you. This topic is about dynamic module federation. Dynamic module federation means that you don't need to know the remotes upfront like it's the case here. You don't know anything upfront. That's why you go with an empty remote section in your host. But at runtime, you can leverage a convenience function like this. I've called it load remote module, and this convenience function gets everything you need to know to load this or that plugin. The remote entry point pointing to this remote here, the remote's name pointing over there, and the exposed module, in our case, one more time, it's the component. So this is, as mentioned, a convenience function. I've implemented it by hand, but at the end of the day, it is just leveraging the Webpack runtime API. It's not that a nice API, it's more of a low-level API. That's why I've wrapped it with this convenience function. And so it's really possible to start the host, to load some metadata from the server, telling you where to find this or that plugin, and then on demand you can load the plugins using this mechanism here. Nice. So now the big question is how to integrate all of this into Angular. because in Angular we have the Angular CLI. Normally we don't deal directly with Webpack. And also for this I have an answer for you. So if you assume you have the CLI here, you know underneath the covers the CLI is using Webpack. But normally, and most of the time that's good, the Angular CLI shields Webpack from us. That means we don't face the complexity of Webpack. We just do ngserve or ngbuild, and the CLI is doing the right things for us with Webpack behind the covers. But now we want to influence Webpack behind the covers because we have a module federation configuration, and somehow we need to find a way to squeeze this configuration into the Webpack configuration created by the CLI. And this can be done. Since the CLI 6, we have this concept of custom builders. So everything we need to do is to build a custom builder, which is tweaking the Webpack instance underneath the covers a bit. And besides that, it can delegate to the traditional logic of the Angular CLI, to the default builder logic. Of course, you could write such a custom builder by hand, but I've already done this. I've published such a builder under the name Angular Architects Module Federation. And it does 3 things for you. First of all, it generates the skeleton of a module federation configuration. That means you don't need to learn this configuration by heart. You don't need to copy paste it all the time. You get your skeleton into your application. Then it installs a custom builder which enables module federation, which squeezes this configuration into the Webpack config used by the CLI. And also, and this is a tiny add-on, it assigns a new board to your project so that you can ngserve several projects side by side, which is what you generally need when going with plugins. So you can download this solution and just use it, or you can fork it or write your own solution. It is really up to you. How can you use this solution? Well, it is not that difficult to be used because I'm using schematics. Just ngedit, then adjust the generated configuration, and then serve your application. When ng-adding it, it is asking you 1 or 2 questions. You can answer it on the prompt, and the rest is generated for you. It's really that simple. Okay, let me show you how all those looks in practice. For this, I'm switching to my VS Code, and here I have already loaded the source code of my workflow solution. What we see here is the configuration for the shell. No, what we see here is the configuration for the shell. What we see here is the configuration for a plugin. And this is not a big holistic Webpack configuration. No, this is just a partial Webpack configuration. It only consists of things we need for module federation. So you don't need to worry that you have to configure all those Webpack stuff by hand. No, the Angular CLI is still doing it for you. What you need to do here is just to configure the aspects for module federation, which boils down mainly to this plugin here, the module federation plugin, which gives the plugin, our plugin with workflow tasks a name. We are also defining the name of the remote entry, holding all the metadata for the shell so that the shell knows how to load the plugin. And here we have the most important section, the exposer section. Here I'm exporting this component under the name download and that component under the name upload. And to prevent that Angular is loaded twice or several times, I'm saying, hey, this plugin is sharing Angular core and the other stuff with the other plugins and of course with the shell. So this is what we need to configure the plugins, to configure the remote. If we have a look into the shell, into the host, we also see that the module federation plugin has been configured, but we don't have set up any remotes upfront. because we need to do dynamic module federation. We don't know everything up front, and so here the remotes section is empty. But I'm defining that I want to share Angular core and the other stuff with the other instances. Then my shell has a lookup service. Normally, this lookup service would do, let's say, an HTTP call to get informed about the configured plugins. Here it is more hard-coded. Here it is telling our application in a hard-coded way that we can find the download task at this remote. The remote entry is located here at localhost 3000, and it is exposing the download task under this name. This name here points to a TypeScript file, and the TypeScript file, one more time, is exporting this download component. Yeah, and I'm doing the same with all the other plugins, like with the update plugin, which also comes from localhost 3000, but also with analyze and enrich, which comes from 3001. As mentioned, normally you would load this data dynamically at runtime from this or that configuration. Here it's hard-coded. Then I've also created something I'm calling the federation utils, and those federation utils just provide a method called load remote entry. And load remote entry gets an configuration setting, I'm calling it options here, from the lookup service and loads this very task, this very plugin. I'm not showing you the full source code of it. You can look up it afterwards. It is a bit crud. It is using the lower level Webpack runtime API. And as each and every runtime API, it is really not that easy to be used, but you don't need to use it directly, just wrap it into a helper function. The looked up information goes into it, and the dynamically loaded component comes out. Now I want to show you how to use everything together within my workflow designer, and for this I'm showing you my proxy component. Every time the workflow designer adds a new task, it is in real adding this plugin proxy. And this plugin proxy only has a placeholder. In this case, it's an ng container marked with the name placeholder. And also, it gets all the plugin options from the lookup service using an input. And now this proxy has the task of loading the real task and displaying the real task in this placeholder. As you see here, I'm getting hold of my placeholder by using a view chart. And also I'm getting injected some internal stuff, some Angular internal stuff I need here for technical reasons, namely the injector and the component factory resolver. And then every time the input changes, every time the host tells me about another plugin to display, I am performing this code here. I'm clearing the current placeholder, and then I'm using my convenience function to load the plugin in question. I'm passing all the data I've received, and then I'm getting back a TypeScript file, a TypeScript module to be more precise. As you know, each and every TypeScript module can have several exports, and here I'm grabbing the real export. This is here something like saying, hey, please give me from the TypeScript module the component that is called download component, but just in a more dynamic fashion. Then I have my component, and for technical reasons, I need to look up a factory for it. That's why I need the injected component factory resolver. When you remember it, I've injected it into my constructor. This comes from Angular, and the predecessor of Ivy really needed factories. Now factories are not a big topic anymore, but to be backwards compatible with the predecessor of Ivy, we still have this aspect in Angular's API. I guess it will vanish in one of the further versions of Angular. Okay, after we've looked up this factory, we can say, hey, view container placeholder, please create a new component, and here we are passing the factory for this component. I'm also passing the current injector so that this component is connected to the dependency injection mechanism of Angular. Well, and that's it. After performing those 4 lines of code, my plugin, my component appears within the view container, which is one more time the placeholder on my page. And as shown before, this really allows us to load stuff on demand into our workflow designer. Quite flexible, if you ask me. Perhaps you're saying now, well, Manfred, that is really awesome. When can I have it? Well, honestly, Webpack 5 and Module Federation can be used immediately. It has been released at the beginning of October 2020. But the Angular CLI must support Webpack 5 too. The current beta version of the CLI already allows you to opt into Webpack 5. By default, it is using Webpack 4 and it works better currently with Webpack 4, but you can opt into Webpack 5. If you want to find out how this works, please look up the README of my plugin. I've described it there. The thing is, currently Webpack 5 is not perfectly supported by the CLI beta. And so it is more for playing around with it and for getting a feeling how it will work. But hopefully, when CLI ships in late fall 2020, CLI 11, then we will have a sound support for Webpack 5. So the future is near, and it looks good that we can at least opt in to Webpack 5 when we get a final release of the CLI 11. I think it will be there in late November, perhaps early December. At least in the last years it was around that. Okay, so the future is really near. We can start prototyping now, and in some months, hopefully, we can use this also in production. If you like this presentation, then perhaps you will also like my free ebook. You can download it here at angulararchitects.io/book. It contains a lot of stuff about micro frontends and module federation, also a lot of stuff about other topics for enterprise Angular. Okay, let's come to a conclusion. We've seen several things in this short presentation. We've seen that module federation is the new call kit, and that module federation allows us to load separately compiled, developed and deployed source code. We've looked into dynamic federation, which allows you to load stuff you did not ever know at compile time. We've looked into micro frontends. We've seen that this is a big deal for creating micro frontends. So you can scale your teams. One team is implementing this application, the other team is implementing that application. They can work separately without influencing each other. And at runtime, everything is loaded into a shell so that the user gets the feeling that they have an integrated solution. But you can also use it for plugins, like I have done in my demonstration. And we have seen for Angular CLI support, you need a custom builder nowadays. I've written such a custom builder. If you want, you can take it. And there is a last thing I want to show you, and I really want you to remember all the time. Please make your applications look a bit like Monkey Island and the traditional PC. Make your applications extensible. Cool. So here you have my contact data. I have already uploaded all my material to my blog. You can download it there, the slides and the examples. And if you want, please follow me on Twitter or on Facebook so that we can keep a bit in contact. Thanks for having me and have a nice day. Mille grazie.